had to go to Timbuktu. No, I have gymnastics flower and 6 hours in the body after. I walk all the way because of my weight. The door was on top of the stall yesterday morning. I don't know if it finds it.
Zip it! Stop talking! That was 40 seconds because I was started recording 40 seconds ago. All right, so we should first talk about parametric equations, what they are. Today you might be thinking like, what's the point? Tomorrow when we get to the applications, you're going to be able to see why we would have parametric equations. If you would take a physics class in college, which some of you will, you might not get to them in a physics class in high school, but if you take a physics class in college, you would definitely cover parametric curves. So you, for most of your math life, have graphed ordered pairs by just taking an x, y, and an equation related to x and y. Like we have y equals mx plus b. We have y equals ax squared plus bx plus c, right? Quadratics. We have y equals e to the x. So for all of functions we have studied so far, you just graph x and y, and that's it. You have an x, maybe you plug it in, and then you outputs a y, and you sketch a picture. So today, we're going to graph still x, y as our ordered pair, but we are going to define x and y as x is a function all on its own, and y is a different function all on its own. And notice I say x is f of t and y equals g of t. Typically, the equation, now I have to add, because I'm saying they're based on another equation, I have to add another variable to the mix. What's the new variable that we see? T. So in parametric equations, t is also often called the parameter. So if you hear me refer to the parameter today, or if I ask some instructions based on the parameter, I'm referring to t. All right. I said that this is mostly application based. Make a wild guess as to what t might represent. Yes, okay. Here's the beautiful thing about parametric equations. Let's take parabolas, for instance. You've learned that you can model the height of an object by a quadratic, right? It's got to have a negative. All right, so that just tells you this is what the path, you're watching my hand, of the equation looks like. But the parametric or the quadratic would just tell you how high it is. It never tells you how far it goes horizontally, okay? What a parametric equation could do is it could define y to be the height, and then you'd have an equation that says, hey, this is how tall the object's going. And then another equation to describe, hey, this is its horizontal distance. This is how far it's going horizontally. Which makes more sense because when we're moving, we're not just usually moving just up or straight out. You're usually moving in a direction that's both. Okay, so that's the beauty of parametric equations, but they're a little weird, so we should figure out how they work. So we're going to graph some by hand. I'm going to also show you how you can get to parametric mode on your graphing calculator. So if I told you to graph x equals t squared minus 2 and y equals 3t, this x and y just represents an ordered pair. But obviously, it's not like before where I plug in the x to find the y. So the weird thing about this is I have to figure out what I'm going to pick for t. So we're going to make a chart of values. So go ahead and we're going to make a table. And instead of just x and y, we're going to have a column for t, a column for x, and a column for y. And usually when I ask you to graph something, I have to tell you the limits of the parameter. Meaning, we're going to just do this for -1 to 1 for t. -1 to 1 for t. Okay, so just for the heck of it, I'm going to just pick a unit of 0.5 or an increment of 0.5. So I'm going to have my t is going to start at -1. I'm going to move up 0.5 from there, so then it's going to go to -0.5, and then to 0, and then to +0.5, and then to 1. You could also do increments in between there, but I think it'll give us enough of a picture. Okay, so here's how this works. If I want to find x, I plug this t in for the equation for x. So let's do that. I'll do it once and then we can do it in our heads because I think we're that smart. What's -1 squared minus 2? And then y would be -3. Now t generates the graph for us, but our graph is still just x and y, so we are going to graph in a minute the ordered pair -1, -3, not because of this -1, but because of that -1. All right, let's put -0.5 in, guys. Put it in your calculator. What does x give us? -1.75. It's helpful if you're doing that too, so you're not like, where are we getting those numbers from? He plugged in 0.5 parentheses squared minus 2. All right, when we plug 0.5 into this equation, what do we get? -0.5, sorry. Okay, so the next order pair we're going to graph is -1.75 and -1.5. All right, let's keep going. This, if I plugged 0 in it, I'd get -2 for x and 0 for y. If I plugged 0.5 in, I get -1 for -1.75 again, sorry, for x and +1.5 for y. If I plug in 1, I get -1 for x and 3 for y. Okay. Am I going too fast? Now let's draw a picture. So I'm going to draw an XY axis. I'm going to plot my ordered pairs, and then you're going to make a guess. What do you think the shape is? Don't. Oh, jeez, ruined the surprise. Okay. So Whitney was right. This is a parabola opening, though, to the right. Okay. The other thing about parametric equations is that, notice I said equations, I didn't say functions, because is this a function? No. It would fail the vertical line test. Okay. So that's how parametric equations work. So you see how they work. Let's show you the parametric mode on the graph. Okay, so we're going to grab our graphing calculators. And we're going to go to the mode function. And there are different, we're going to deal with several of them this year. We're in function mode. That's where you've been for your math career. Do you see right next to function mode? It's yours might be pair. Does it PAR? Mine says parametric because I have a TI-84 plus CE. We saw a Viper edition the other day on we don't know what the difference is, but it's ridiculous. All right, did you shift it to parametric? You're going to hit enter. Okay, you ready? Now you go to y, and what do you notice? Instead of y equals, what do you see? X and y, because for every parametric equation, it has to have an x and a y, okay? What automatically is going to happen is, you see this button which says x comma t comma theta comma n? Now that you're in parametric mode, when you press it, a t is going to show up. All right, let's put our parametric equations in, and then I'm going to talk to you about window. Yep, t squared minus 2 is our x, and then 3t was our y. Okay. Now, remember how I said in the graph, do we see t on this graph anywhere? But we had to pick t in order to generate those points, right? So when you're going into window, you are going to see a t min and a t max, and that's where we would put, in this case, the negative 1 to 1. I'm going to show you how you can change it to other things. Here's what I'll tell you about t-step. If you make that bigger, what it does is it draws the pieces as jagged pieces, because it's only going to calculate those t values. So if you want it to be smoother, you want t-step to be smaller. If we're graphing on our calculators, I would make it at least 0.1. When we do it by hand, that would be a lot of work to make it 0.1, wouldn't it? If I had made it 0.1, I'd be doing that a lot. But on our calculators, yes. Then, once that just tells us this t part, this x min and x max is just a regular window. So if I wanted to do a regular window, I would maybe do negative 10 to 10, x min negative 10, x max 10, scale of 1, y min negative 10, y max 10, scale of 1. All right, are you ready?
Yep.
Hit graph. Okay. Now, what else do you notice? Why is it just cut off? Here's what you can control in parametric mode. We're going to use it to actually simulate. You're going to be able to see on your screen tomorrow the motion of an object. T controls where it stops. So why did this stop? Well, because I only told it to graph from negative 1 to 1. So if you want more, what if I made t min negative 2 and t max 2? Then you'd see more of the graph. Yeah.
Oh.
Kind of cool.
What?
Never knew that existed on your calculator. Okay? All right. We'll do more with the calculator tomorrow. Are we all, as long as you know how to graph and kind of mess with it at this point, we'll do more with it tomorrow. Okay. The last thing we're going to do is, what if I wanted to take this and write it in function mode the way I've always written equations? So what we call this is eliminating the parameter. Okay, eliminate the parameter. And when I say that, all I'm saying is we're going to just get rid of t. We're just going to get rid of t. So I'll do a couple examples. The first one we're going to try is, what if x was 1 minus 2t and y was 2 minus t? Okay, so this is going to take us back to some elimination. So as long as you know how to do elimination, you're going to know how to do this. You're going to pick one of the two equations, whatever one you feel like is easiest to work with, and you're going to get it so t is alone. So which one do you want to do, x or y? Okay, let's do x. If I wanted to get t alone, I would first have x minus 1 equals negative 2t, correct? And then if I divided both sides by -2, t equals x minus 1 over -2. You following so far? Then you're literally going to take t out down here. And you're going, because t equals this, you're going to put that in its spot. So y equals 2 minus x minus 1 over -2. Now if I went back to function mode, so if you graphed this in parametric mode, and then I went back to function mode and I graphed that, you get the same graph. Okay. Let's see. How do we, let's do another one. Just one last one. And then we'll do some whiteboarding. Okay. What if I did this one? What do you think would be the easier one to get t along? Yeah, I think it would be y, because all I would have to do is flip these two around, right? Couldn't I add t to both sides and then subtract y from both sides? So then we'd have t equals 5 minus y. Okay. And then we could put it up here. Be careful though, what am I doing with t? Squaring it, so then I rewrite it. We got x equals 5 minus y squared plus 2. And if I wanted to expand that, we're not going to kill any cats today. It'd be 25 minus 10y plus y squared plus 2, which is y squared minus 10y plus 27. Okay. I don't know how far you got in Algebra 2 with quadratics. Did you do, you don't know either. Did you graph parabolas right and left and ellipses and things? Did you do a foldable about that? Really? I'm not, because he used to do foldable with that. He used to do foldable with that. If y equals x squared is a parabola opening up or down, x equals y squared is just a parabola opening right or left. This is just a parabola opening on its right. You cannot graph this in function mode. Your calculator can't do that. However, if I would put this in parametric mode, you could graph it. Okay, so the other thing that's cool about parametric mode is it allows us to graph things that are not functions, because we have to have a y equals alone to be graphing functions. So, all right, tomorrow, for all you baseball fans, we will do some simulations.